All right, so for today's class, we'll be focusing on working with files and JSON. Right, so it's a very interesting concept, especially if we intend to have a persistent means of storing information without necessarily, should I say, without necessarily losing that information, or should I say, going extra miles to acquire a database, right? So we can actually work with files, and we can save, and we can write to or read from files as well, and make use of JSON to store a more structured information, right? To store a more structured information. So without wasting time, and so that we don't move between slide and our code, we will do everything on VS Code as usual. So I'll navigate to my VS Code, and of course, we will do every point and every details of this class. I will put it down there on VS Code, as we've always been doing. All right, so real quick, I'll go to my folder. So I already have this open in VS Code. So I'll simply just open it up right here. So this is where we left off in our previous class. The very last class we had, this was what we were actually doing. So as usual, I will create a new file for this new concept, right? And then add it to the collection of all our files that we've created so far. Right, so far we've done so many concepts. So we've done about 6 concepts so far, right? Some files have like more than one concept, like function and error handling, right? So go ahead, and then I'll create a new file, and now, and now for the purpose of arrangement, I'll start with 7, and I'll call these files and underscore and JSON dot py. All right. So files and JSON dot py. So what exactly is files? So basically, when I mean files, I'm basically referring to our text file. So our text document. So our text document, that's basically what I'm actually referring to, right? So we can work with text documents in Python, right? We can manipulate, or we can write to, and we can also update what a text document using Python, and this is very useful if need be that we need to have a persistent means of storage. So before now, what we've been doing so far is something like this. Let's assume that we want to store a list of names, assuming that we need to collect the list of available names and probably save them, and then use it sometime tomorrow to let's say to mark attendance and stuff like that, right? What we would basically do before now is maybe we will have a list of names, okay, and then we'll simply just have an input option where users can insert these names, right? So I would have an input option here saying user names, okay, and then there should be an input, and there is no point to type class because of course names is a string, right? And here I'll say enter name, and then I'll basically do what we'll simply just say names dot append, and we'll keep adding these names to our list, okay. Let's put the usernames, okay, and we could put this in a loop so it runs forever, because we never can tell how many users wants to register in this application, right? So I would indent this. I would indent that, and then basically I'll just keep printing after every indentation, right? I'll keep printing our names, right? Our names. So I don't intend to loop this particular variable for names, because of course names should be one static means of saving all our names. So now I need to run our code, and then I can come here, and then I'll insert the first name. Probably let's say the first person's name is, let's say, person 1 as first name. Of course, that name has been added to the list, right? And this one name could be person 2, all right? And then it keeps adding to the list. Of course, this actually helps us store the information, right? But then this also have a limitation, right? So now the problem is that if we close this program, then everything here gets wiped out, right? There's no means of us retrieving what have been saved already, right? Without without us doing what bringing database. So for now, files can help us solve this problem for now, right? Where we can have what we can write this information to a file, and we can do what update it and retrieve from it, and as well leave it there and it will save without what without the fear of what of this thing will get wiped out if we end the program. Right, so it will only get wiped out if, for any reason, we manually go into that file and delete that file completely or clear out the entire file. But which I don't think any of us would internally want to actually do that. Okay, so we'll see how we can work with that. We'll see how we can work with that. So I will clean this up, right? And then if I should run this again, of course, we said about that what we have is no longer there. So even if I was to add person 3, right? So what that person 1 and 2 is nowhere to be found. It's gone, right? It's lost in space. That's what happens once you do what once you use in-memory storage like this, like list, dictionary, and the rest of them. Of course, each of them can serve their own purpose, right? But then in the case of persistency, then files can play a very wonderful role there for us. Right. So Mr. Trump, your hand is up. Please ask your question.
Sorry for cutting you short, sir.
Right.
I was disconnected for 2 minutes. I came back, I saw person 1, person 2. I don't know where they came from. I don't know if you can just repeat it quickly. Sorry, sir.
Okay, person 1, person 2 came from okay, so basically I was trying to explain the concept of how we've been writing our code so far. And in a case where we need something saved for a longer term purpose, if that we may likely need to do what to append this information to a list or to any available data structure. But there's always a downside to this kind of things, because the moment we execute this code and then probably we start saving this name to our list. Let's say, assuming the first person is called person 1, okay, and of course that gets saved to that list, and then assume that we need to save another person. Let's say person 2 in this case, right? Of course that also gets saved to that same list, and it works kind of, right? But then it means that our program needs to keep running from now to the end of time. And for any reason that we close this program, everything that is saved there is wiped out, because this kind of storage is in memory. So it's only active as far as what your code is executing. So if we end that execution, everything gets wiped out, right? So if in the case that where we need to come back and run this code again, and then probably add person 3 to the existing list, then we get to see that if we type in this new person called person 3, and then click on enter, we only have person 3 now available, because we close the program, the previous things that we saved get wiped out. And that is not what we want in some cases, right? But then it doesn't mean that data structure doesn't play their roles. Of course, they play their roles very well, but then they also have one limitation, which is they cannot actually hold information over a long period of time. Right? So that is where files can come in, and then we can do what? Save these things to an actual file, which is not actually a good technique, but then it does the work, right? It's far more better than just saving these things in data structures, right? So that is basically what we were trying to explain. Please confirm that we are on the same page, so I can proceed. All right.
Yes, sir. Thank you, sir.
Okay. All right. So now, having that in mind, so how do we now resolve this problem, at least for now, right? At least for now, because over time we won't actually use files. But for now, how do we now solve this problem with files? So that's where working with files now comes in, right? So remember, files, like I said, are basically what our text documents. When I mean text document, I simply mean a document that you can simply go to anywhere in your operating that you can simply go anywhere in your device and then create that file, right? But in my case, I'll create the file here for easy accessibility, right? For easy accessibility. Don't worry, I'll show you. If this file is not here, I can still show you how you can use other means of reaching that particular file. But that will be in our next class, because in our next class we talk about some models. So because in that other option grants us to make use of certain models, we cannot use that option. So for readability's sake and for accessibility's sake, please let that file be in the same folder with your current file, which means it should be in this folder that I am right now, right? So I can create a file here, and this file I can call it names.txt, right? Name.txt. Because this is our simple document file, of course. And of course, I can still come here and write basically anything within this file, because this file is basically a string of text, right? It's a text file. So in it means that everything here is in quotes. So this file, please, you do not write your code in this file. Please, this is a text document. It has nothing to do with Python, right? So your Python interpreter will not come and execute your instruction here. Please, this is your normal text file that you can open using your text editor or whatever text editor that you want to use. But then this can be manipulated with Python, right? This file can be manipulated with Python. It means that we can read from it and we can write to this file. Okay. So now, how do we do this? How do we do this in Python? So that we can do simply have this thing saved up for us. So it's pretty simple. It's pretty simple. So first of all, we have a built-in function that helps us to do this. So thanks to Python, we have so many things already in place for this kind of situations, right? And this function is called open. So the open function is basically is a built-in function. It's called open, right? So it's basically used to open text files, right? So it's used to open text documents. And by text documents, I mean any file with an extension .txt, right? Please. So basically any file with an extension .txt, and of course that's what that function is used for. And we can do what we can. You also use this function to do what, to carry out the process of opening a text document. So I'll go back to my text document, and then I'll assume that this document, I have some names here. I'll call this person 1, and I'll call this person 2. I'll call this person 3 as well, right? And so on and so forth. So assuming these are my text. Of course, your text can be as long as it can be a full-blown text, a full-blown story, right? It doesn't have to be person 1, person 2, person 3. It's literally a text document. So it means that even if you have another text document in your device, you can copy it down here and manipulate it, and it will work, right? It will work. So, but I'm just leaving this one here as assumption that this document already exists and have some text called person 1, person 2, person 3. And of course, I can manipulate, I can open it, I can read from it, and I can also write to that file. So what do? I simply come here and use the open. So I'll simply say open, and then this open takes in 2 required arguments, right? So I put it here. It takes in 2 required arguments. So the first one is the file location, right? The second one is the mode, right? So this mode is optional, right? Well, it's not really optional though, but don't worry, I'll explain to show you what I mean by it's optional or not optional. Okay, so the first thing this man takes is what is your file location in string, right? In quotes rather, right? So I'll come here and I'll put my quote and then my file location. So since this file is in the same directory as my file, right, as my Python file, I'll simply just put the file name there, right? But then if this file was not here, then we have referenced the full part of where that file is located. But since the file is in the same directory, I simply have to put what the file name.txt, right? But if this was not here, please, then we have to do what, to reference the full file part, which I will show us in the next class. All right. So I'll simply just branch out of that class and just show us how we would have done what, reference that directory if the file wasn't there, right? Because that other method needs us to make use of a module. And since I haven't covered module yet, so we cannot actually go via that route. But for now, please let these files be on the same folder, and simply just put in the file name there, right? And then Python will simply know that that file is in the same directory as your Python script, right? So the next part again is the mode, and of course the mode are plenty. We have several modes in which we can open our file. So by default, it means that even if you don't put a mode, by default we have the read mode, the arrow mode. We have arrow mode. The arrow mode here stands for read mode. So by default, Python always thinks that you want to read from the file and not write from the file. So that means even if you don't specify this mode and then you open, of course, it works and you can read from it. But then when you try to write to this file, you have an error that we cannot write to that file. So that's what I mean by what that mode is optional, right? So it by default it's what it is set to read mode. But then if you intend to open up in any other mode, then you have to explicitly specify that particular mode, right? So we have the read mode being what that R, and we have another mode called W, the write mode. So this one actually writes to the file, right? So basically this mode writes, right? So you write to the file, and it also, of course, it also overwrites existing text in that file, right? So if you use write mode, it will overwrite whatever text is there, right? And then we have another mode called A. A here means append. So of course, from the name, it means what it adds to the existing file. So this one doesn't really overwrite. It simply adds to the existing text, right? It adds to the existing text. Excuse me. Right. So this one here is X. Right. So X here simply means that that if the file that we intend to open, right, is not available, that it will create the file, right? It will create the file. So it means that if the file that we intend to open, it will create that. Sorry, it means that if the file that we intend to open is not available, right? It means it will do what? It will create that file. But if that file is available, it will throw an error. The file, because that file already exists. Okay, that's basically what X there does, right? So I'll put here that it will fail if exists, right? So if that file already exists, then it will do what? Fail, right? So we have every other mode, but then these are the mostly common file mode that we will likely use. So we have other existing mode, which I will leave it to us that in aspect them we can do what we can look up these other modes. But apart from that, this 4 is good to go. Question before we proceed. All right, so silence means that we are following so far. That's fantastic. All right, so remember by default, your file is always in read mode. So I'll put this by default. By default, your file is always in read mode. All right, so after opening this file, now what do we now do? We can simply do what? We can simply read from the file, right? We can simply read from the file. So how do we do that? We simply just say, so I'll simply assign this whole operation to a variable called file, and file will be equal to what? Open. And then I would simply just say file.read. Of course, I'll just simply just print this man. So I'll print this man, and if I should run this now, then every content in our text document actually comes up, right? So we have some built-in function when reading a file. Okay, so we have some built-in function. Okay, so let me just section these things, right? Let me section these things so it makes a lot of sense, right? So first of all, we need to do what? Open the file. So firstly, open the file, right? Open the file, and which is what we've just done, right? Firstly, we have to open the file, and then the second part is that you can choose to read the file, right? Read from the file. All right. So there are a couple of ways that we can read from file. There are a couple of ways that we can read from file, right? So one of the functions that we use in reading from files is the read lines, right? So we have the read method, right? So these are all file methods that we use in manipulating files, right? So we have the dot read, we have the dot read lines, and all this one works for when reading from files. So we have the dot read line, we have the dot read lines. Okay, we have the dot read lines with S, right? And each of them works separately. So the read actually reads the entire file, right? So this other one reads the entire file, right? So this one reads the entire file, and this other one reads the first line. So this one read the first line of the file, and this other one here would simply read all the lines into a list, right? So basically the read lines will do what? Will carry each of the line and put them in a list. That's basically what read line does. Of course, we'll see how each of them works, right? And so that it makes a lot of sense. So the read, like I said, the dot will read the entire file. So if I run this now, I should have everything within that file coming up, right? So I have everything within that file coming up. And then if I should join this to read lines, of course, read line does what? And read line read the first line, right? It reads the first line. It reads the first line, which in this case should be what? Should be person one, right? It reads the first line, which is person one. And then we have read lines. Of course, this one will read every line into a list. So basically, that means I should be expecting list at the output of this particular method. So if I should execute now, I have the entire line as a single item in the list. But then you can see that there's a special character there, read line. This character here that looks like this. So that character there is a special character is a special string character. It's a special string character that signifies a new line. So basically, there is a new line after our first line and second line. So if you go back, we have our first line, and then invisibly, right, there is a new line that is there after that first line. That new line is what responsible for this other line being in a new line, right? And there's also another new line here, which also responsible for this other line being in the next line, and so on and so forth. So that line is added by default after every line in your text document, right? After every line in your text document. So what you can do is you can either look through it and do one and strip it out. There is a built-in string function called strip, and this function basically removes every new line element, any new line element within a string, which we can do that, right? You can look through this list and do one and strip out all those new lines. So basically, what I mean is that you can have something like this. I could say this would be my initial reading, right? Init reading. So I'll send this to a variable, and then I'll do what I'll simply say for line in initial readings. Remember this initial reading, right, is a list of all our lines. Okay, so I will simply just say I will create a new variable, and I'll call this final reading, or should I say strict reading rather? Strict. I'll call this strict reading. Okay, and then this will be an empty list, and then I would simply just say for each line, I basically want to append to the strict reading, right? This the strict version of this line. So line dot strict. So I will strip this off, and then I can now finally come here and do a print my strict reading. So this should now give us the stripped version and the of what we read from the text document. So if I should run this again, I should have in unexpected character after line continuation at where. Let's see. Oh, let's see where we have a problem. So it comes from, okay, sorry. So we should have commented on this out, sorry. So line 20. So let's run the code. And so we have a more clean version of what we have earlier. So that's basically how you can do a read from text documents. So you can use any of these functions and do one and read from them. So, but there's a law, or should I say, it's not recommended that after reading from a text document that we should leave it empty like that. So it's always recommended that after reading, we do what, like after opening and reading then you know what that should always do what close your file. So I should have file.close. So if you don't close your file after opening it up there, if you don't close it down here, then you may likely have memory situations, problem that tends to memory, right? So there's always a tendency that there's always a possibility of whatever you've written to a file may likely get lost, right? So it's always recommended that after opening and reading from it, or probably writing to it, then you will always close back the file, right? Always close back the file. So you can't just leave your code like this, right? And let it run, right? There's at some point you will likely have either losses in the text document or memory issue, as this file is likely open from now to the end of time. If your program keeps running from now to the end of time, okay? So please always close. So if I run this now, of course, this will run as expected, but then our file was closed at the end of it all. Our file was closed. So these are the functions that you will likely use to do what to read from a file, right? Those are the functions that you likely, or should I say, the method that you likely use to do what to read from a text document. Question before we proceed. Question before we proceed. Question. All right, so there's no question. It means that we are following just fine. That is fantastic. All right, so now that we've seen how you can read from file, how do we now write to file? So it's similar, or it's almost the same thing to what we've been doing so far. So Blessing, Edo, your hand is up. Edo, rather. It's on me and ask the question.
Sorry to, but you can you please go back again and start with this dot strap.
Okay, here.
Yes, because I was following before. They now highlighted it as comments, then it started getting confusing again.
Okay. So okay.
Thank you.
All right. So let's undo. All right. So the dot strip is a built-in string method, similar to how we have dot read being a built-in file method. Also similar to how we have dot append being a built-in list method. We also have dot strip being a built-in string method. So string has a lot of string has a lot of built-in method. Which if you simply have a string here, let's say a string of hello, and then you simply come and say dot, you see these are all the methods available for string. And if you apply this method to a string, of course it does certain things to that string. Okay, so same thing, string also has what we call strip. So if I should scroll down, there should be a strip somewhere. Strip. So this method here, strip. So basically, what this method does is that it removes spaces, or it removes special character from your string, right? So there are special characters in Python that if you put them in a string, it sees it separately, like it sees it as a special character in a string. So it doesn't really print that character. For instance, it interpreted it to a special way, right? So what do I mean? Let's say we have this character here. There's this character here called \n, right? And then if I should have \n and then having like word there, right? Now by right, you feel that if I should print this thing, everything should show, right? Everything should show as it is from hello \n word. But then you'll be shocked that if I should run this code right here, that will have one hello word, and that \n will not show. Why? Because that \n is a special character in the string and is seen as a new line. It means that after hello, this means what? This is like our enter key, means go to the new line. Right? So \n is a special character in a string that is interpreted as a new line. So basically, that is what that character does. And basically behind the scene, we have that character here behind the scene, but it's not visible to you. But then if you process this text file with Python, then you see that every time we hit enter key, we automatically added that special character to that text, right? So that is why when we now said, okay, let us use read lines, when we now say let us use read lines, because remember read lines, we do what we will read every line in the text into what? Into a list, right? So if I come back here and then I print my init reading, right? Then I'll have a list of all the lines in that text document, right? I have a list of all the lines in that text document, but then there was something added, which was that special characters. Remember, this special character is for new lines, so it's similar to us doing enter, right? So for each time there's enter in a text document, right? That enter is being recorded in Python, right, as a new line symbol, right? So now if we intend to do what to fetch all the line as a list, right, we will always have this problem of having that new line, right, of having that new line character. So now an answer that what that since we have a strip that is job that found that in that strip method, the job of it is to remove any of this character from a string. That is what that job does. Or sorry, what that strip does. It removes any of that character from a string. So what we can do is that, okay, fine. Now we can do what we can create a new list called strip reading, and then we do what we look through in each reading that contains this special character, right? And then for each of the item here, right, we do what we simply strip it off and then append the results to the stripped reading list without that union again. And then at the end of it all, we do what we simply print the stripped reading. And then at the end of it all, we then simply do what close the file, because every file open must be closed. So if I should now run this now, we have the list without those new line characters. Do you understand? Mr. Blessing, are you with us?
Yes, sir.
Right. So any other question before we proceed? Any other question before we proceed? All right. So the silence means there's no question. So, but then there is a more convenient way that we can always open our file without necessarily explicitly doing what comment to put file or close. Because with that method, we can simply open the file, and by default, after your Python has finished executing the code within that block, it will close the file automatically. So that way, we don't have to explicitly always come back and close the file. And that method is to open the file with a keyword called with. So there's a keyword called with, right? So use with this open keyword, and then it's a more recommended way of opening your file, right? So basically, what I will do instead of doing all this again, sorry, I'll just turn this off, and then I'll comment on this. So instead of doing file.open, so that because if you do file.open, you must find what you do, come back and do file.close. That is just how it should be. But then to save you the stress of going back to do this file.close, what you can do is you can open this file with a special keyword called with. So if I use this keyword called with, you know that I want to open a file. So it takes the open function, and then with this function, you can do what you can simply pass in, of course, your file, which in this case it will be our name.txt, right? And then at the end of it all, I will say open it as, and then I'll give it a keyword. I'll give it a variable name, or how do I want to reference this file that I'm opening, right? So here I can say as file, right? So this is me simply saying file equals to open, right? So now this variable file is what I'm putting here. So I'm simply saying open, use this keyword with and open this file, and I want to reference that file as a variable called file. Are you making sense? So this whole thing here is similar to us doing this file equals to open, and then going forward to know what to access that file with the variable name file, like what we've been doing here, right? So that is basically what I'm saying, or what I'm doing there. So with that now, I can simply inside this code block, I can manipulate this file. And the moment I step outside this code block, it means that file is what will be automatically closed. So if I should now come here and say print file dot read. Remember, okay? And then maybe outside here, and then I can simply come here and just say print done. All right. So now, before Python will do what we get to execute this instruction, all right, it will execute this one first. And the moment it finishes executing that one and gets to this point, it automatically closes that file. So instead of the stress of coming back to do what, to manually close that file, right? So that is the whole point of opening this file with. So this is the most recommended way of doing this. So if you do this other way around, then always do what, always come back and do what and close it manually. But with this, it's much convenient, right? You simply just say with and then open up this file, and then how do you want to do what to reference this file that has been opened up? So you give it that variable. So if this was like hello, then mean that here would be what hello, right? That's basically what it means, right? That's basically what that actually means. And then I can do what I can do all my manipulation inside this structure, right? So everything manipulation will come in as an indented part, right? So it means that once I'm done with manipulation and then Python has finished executing that instruction, then it will automatically close that file for you without you going to the stress of coming back to close that file. Is that making sense? Does that make sense? All right, so the stylus means that actually makes a lot of sense. All right, so we'll be doing that instead of the other way around. So of course, if I run this now, our code will still run just fine. Our code will run as fine. All right, so it means that before we get to done, this file was closed automatically, right? Before we get to that part of done, the file was closed automatically. All right. Okay, so now we've seen how to read from files. Now, how do we now write to this file? Because I think that is also an important thing, because we won't only be reading. How do we now write to it? Well, how do we now write to it? So to write to files, I would simply come here and I would clean it off, and then I'll copy this, paste it down here, and I will put this writing to file. So this should be writing to file, to the file, or to file, however you want to call it, right? So now how do we write? So we also have, similar to how we have built-in method for reading, we also have built-in method for writing. So to write, we also have, of course, we have the .write, and of course, by now you can guess what .write does. It writes it writes everything to the file, right? So here it says it writes a string to the file, right? And then we also have write lines, write lines, and write lines as simply write a list of string. So this man here takes in a list of string and then puts it there. And so he writes a list of strings, right? That's basically what a write line actually do. Right? So now let's see how we can write to our text document. All right. So now remember, if we are opening, by default, it's in read mode. So that means in order for us to write, we have to do what, to open in write mode, so that it gives us permission to know what to write to that file. So what I will do is I will simply come here and do what, and put my comma. Remember, this open takes in two arguments: the file location and the mode. File location and mode. So I'll come back and then I'll put my mode, and my mode here will be W. W being what? Write. It means that I want to write to that file. I want to alter the content of that file. So what I now do is to do what? Is to say file dot write. And remember, write actually override the content of the file. Remember, write actually this write mode actually override the content of the text of the text document. So if I should now come here and say write person 4, right? It means that what, it will clean everything here and just put person 4, right? It will clean everything and do what, and put person 4, right? And if I should go ahead and run that and comment on this, and then at some point I want to read. Remember, you can do one thing. You can only do one thing at a time. Either you're writing or you're reading, right? But you can't do both. So I just put reading here, And then basically what I want to do is if they are writing, if you're in read mode, you cannot write. If you're in write mode, you cannot read. Right? So it means that I cannot use write here because I've said that this should be what a read mode. So we cannot write. So if we try to write in a wrong mode, then it will turn error. Right? So I'll simply do what read. And I'll call this I'll simply just print rather. Let's just print this. So I'll just print this man. So I'll print this man. All right, so let's run now and let's execute. So I have person 4. Remember what we wrote. So we write to the file, and as we know, write does what write overwrite everything in that file. So basically, it cleans everything from the file and put person 4. Right? That's what I have. So even if you go to the file and clean and open it, right? We have that text there, and that text will stay there, right? Except do what you programmatically do what delete that text. So that means it's safer to do what to save things there. So if I was to comment on this out, right, and then end the program and run again, I also have my person 4 still stored there, right? My person 4 is still there, except what I have to explicitly either programmatically I delete what is there, or I come here and do what I'm deleting manually from here, right? But apart from that, whatever you put there will stay there, right? And will stay there from now to the end of time. Question. All right. So you may be wondering, what if you don't want to overwrite? That you simply just want to keep adding to what we have there, right? What if yeah, so that's basically what I want to talk about, right? So what if what if you don't want to overwrite? You basically want to add to what is there in the file. Then you can do what you can open up the file in append mode, because this both the write and the append, right, for writing to your file. So I can simply come here and put A, right? And A there means append. And let's come here and I'll change this to person 5. You see that if we go back to our script, we should have 4 and 5 there now, right? But not everything being overwritten completely. Let's say if I come again and run this code, I have person 4 and person 5, right? So append simply means add to, right? So it's similar to concatenate. So it joins this new text to the existing text. So if I wanted to have space there, then I will simply come here and put space here, right? So that when it goes, when it goes there, it gives space. So I change this to 6. Remember, we are still in append. So append will keep adding to the file. So if I should run this now, I have my person 6. All right, or better still, I can just simply put all of them in a new line. Better still, or basically I could just be putting new line after adding all these things. So I put new line after adding all these things. So it means that after adding a new line, right, and run this now. Of course, of course, person 7 is still on the same line, but then if we try to add again, I believe it should now add on the new line. So if I run again, I have person 7 on the new line, but add another one, person 8. Of course, person 8 should now go on a new line also, and so on and so forth. So that's basically how you can write to your file. That's how you can write to your file. Question. And then if you consider that if you open up that file, of course, everything that we've done so far is there. See, it makes a lot of sense. It saves you from ever thinking that if you close your program, you lost what you have so far. No, you will not lose it. Everything is still intact. Everything is still intact. Question. All right, so Mary Jane, your hand is up. Please unmute and ask a question.
Okay, good afternoon, sir. Can you hear me?
I can hear you.
Okay, I want to ask if the file structure, if they must all be in the same folder before you'll be able to access the file.
Not necessarily. So remember, I said that this file can be anywhere in your operating system, and it can be anywhere on your device. But in order for us to go and fetch that file from where it is down to this so that down to a point where you can actually manipulate it. Basically, in order for us to get that file location, we have to bring in a model, right? A model that can help us to manipulate our directory. Okay, but since you haven't covered model, so we said that we cannot use that approach. But I said that for now, what we can do is that we can put the files in the same folder, and then so that we can do easily reference it. But then if this file is outside this folder, then we have to do reference the entire file path, right? But we haven't gotten to a part where we can do use that. So we leave it as it is. But then it's not necessary that this file must be here. It's not necessary. Okay. Have I answered the question?
Yes, sir. Thank you.
All right. Okay. So that's basically how you can manipulate text files. But then there is still also a down, right? So now the thing is that your text file is only limited to strings. So it's only limited to strings, and it's of course it works if you intend to store strings, right? If you intend to do to store strings, of course it will do work. But what if you wanted to do to store a structured data? What do I mean? What if you wanted to have something like this? Maybe have a list of names, right? Let's say you have a list of names, all right? Let's say you have a list of names. Okay, let's say names. Excuse me. So let's say you have let's say you have something like this: names equals to a list of names. Okay, and you can have a KodeCamp. You can have KodeCamp. Let's say 1.0 and so on and so forth. Assuming you have this list, right? But then you want to also store this list in our text documents. So the thing is that we cannot store the list because the moment I try to say, okay, let us write to let's write that name to our text documents. This is what that if I try to execute this, I have a problem saying that this man only writes strings. So this man only accepts strings. So we cannot write it. It's difficult to write it. And even if you want to convert this man to a string and then write it to this text document, when we want to retrieve information from it, it's coming as a string. So it's even more harder to even start manipulating this list in that text document. Right. So now, what do we now do? How do we now store a structured data, right? A more structured data if we had one. How do we now store a more structured data if we had one and not just only strings? So that is where Json comes in, right? So Json is a means of storing, or should I say, Json is basically a standardized format of exchanging information, right? But then your programming language can process that structure. So let me put that in writing so it makes a lot of sense. So JSON is more like so in a case, right? In a case where we need to store a structured data, then we can use JSON, right? So you will hear more of JSON because this is actually where you actually use them the most here in backend, right? So, but let me just give you a brief introduction to what JSON is. So JSON is an acronym for JavaScript object notation, right? It's an acronym for It's an acronym for JavaScript object notation. So basically, what this thing is it is a standardized, but it is standard, right? It is a standardized means of storing and exchanging structured data. Basically, it doesn't really have to be structured data, though, but then it's a standard way in the web world in which information is being exchanged. But don't worry, we will explain it better in our future classes. But basically, what I mean is that since this is like a third-party kind of structure, remember this structure has nothing to do with Python, right? It is a standard structure in the web, in fact, in software development world. It's a standard structure in software development world that is used to store and exchange data. So it is programming language independent. So it means that Python can process this language. And that Python can process this structure, and JavaScript can process this structure, and C++ can process this structure, and PHP can process it. But every programming language is a must. As far as programming language goes, right, that language must process a JSON object, right? It is a standard, right? It is a standard. If not, then we cannot consider that as a programming language, right? Your language must be able to understand and process what a JSON structure. So a JSON structure is similar to our dictionary. It's very similar. In fact, they are the same. But then some things actually differ. So it looks like this. So it looks exactly like this. So I can have a name, and then I can have hello. I can have like let's say KodeCamp, and then I can have age, and then I can have let's say 50, right? This is basically how a JSON structure looks like. Of course, it looks exactly like our dictionary, right? But then there are certain things that actually differ, right? I think a JSON structure, right, does not actually support our Boolean value. And let's say we have something like this. Let's say it's active, right? It's active. Let's say we have it's active as an element, and then this man should take a Boolean value. So it takes in small t as Boolean value, true or false, right? So remember, our own dictionary takes in capital T. So it's almost the same, just few differences, right? But then, because it is a standard structure, Python can process it. So it means that you can take this structure, right, and give it to Python, and Python will convert it to our native dictionary and work with it just fine, right? So and then take the same structure, give it to PHP. PHP will work, you convert it and work with its own native data type. Take the same structure again and give it to JavaScript. JavaScript will convert it and work with it just fine. Give it to C++, the only one will convert it and work it just fine. So this structure is a standard, right? It's a standard way of structuring data in order to want to exchange this information or store or exchange it, right? So you can store, you can also exchange it as well, right? And talk about this exchanging sometime in our API building. But for now, let's focus on storing, right? So this is a more structured way of storing data, similar to our dictionary, right? It's similar to our dictionary. But then remember, our dictionary lives and dies in our programming code. So it means that if this was to be our dictionary, that once we close our software or our program, everything that we have stored inside there is gone, right? So, but then JSON can also be a file. It can also be a file similar to what to text document. So I can come here and have another document or another file called names.json. Right? And it looks like this. So basically, it means that I can copy this structure and put it there. And of course, that is how a structure of a JSON looks like. So you can see that it even gave it some wonderful color. Today, that is what the actual structure of how a JSON data should look like. All right. So this is basically how it looks like. Right. This is how it looks like, and then we can do what we can. Since this structure is understandable by Python, it means that we can simply manipulate this file, right? Because Python can do what can interpret this structure into what our native dictionary, right? So it means that we can manipulate that file, right? And then write to it and do what and write to it and read from it as well. Okay. So to have a more should I say a means of saving a structured data, what we can do is that we can do what we can have a JSON file, right? And of course, the structure of it is similar to our dictionary, just some few differences, like in how their Boolean value is called. Okay, so their Boolean value actually is what lower cases and not upper cases. I think there's another few different like that, but I can't actually think of one right now. But we have about 2 to 3 differences that differentiate this structure to our native Python structure. Okay, so having that in mind, so we can know what we can simply do what manipulate, right? We can manipulate. So what do? We can simply write or read from that file. And it's similar to what we've done so far. So basically, what do we do? Python has, okay, we still have to actually involve models. Okay, please. So for the sake of this particular concept, I'll bring in models. Don't worry, you don't have to understand everything that is happening there. But basically, in order to save or to store a structured data, since text document doesn't work, that we can store it in a JSON format, right? So basically, what do? We can create a JSON file and then store it to that JSON file, and it will store it in a structured form. So, but then in order to manipulate JSON file, we have to do this. So we have to type in import JSON. So you don't have to know what this thing does, right? Just know that don't worry, tomorrow on Thursday it will make a lot of sense. So basically, this is what we call importing of models, right? I still feel that I should leave it, and so I should not complicate things. And probably we can come back to this concept after we've talked about models. So I don't complicate things. I don't want to bring in a concept that I have not fully explained. So I'll leave it there. Please, I'll leave it there. I'll leave that just when we talk about model, we'll talk about how we can use that here. Please, I'll leave it there. Right, so I'll leave that JSON as it is. So please, so far we can only manipulate file, and I'll try to limit our tags. Right, so okay. So the good thing is that we will still do JSON, right? So okay, so the tags still remain as it is because it's already prepared. Also, it covers this concept here, right? So it covers this concept here. Where we have to actually further make use of certain things from that model, right? So you have to actually, so we're starting to do something like JSON.dump. It doesn't sound strange. So let's just leave it, right? Let's come back and talk about it on Thursday. Right, so for now, we just stop there for today's class. We cannot proceed without models. Probably models should have come first. Before I think that's an oversight in that curriculum. Since I apologize about that, an oversight in the curriculum. Models should have come first before this class. Right, so we leave this class here and then we continue on Thursday. Please, any other question pertaining to how we can manipulate text documents? So far we can only store strings, but we cannot store a structured data like list, tuple, dictionary, and the rest of them. So we cannot store those kind of structured data for now. But we can do what we can write. We can edit text documents. Of course, you can have do what? You can write to a document, you can append, you can read, you can as well create, right, a document file if it's not there. That is what X does, right? So if I try to open this, let's say I try to open something like, let's say, named with multiple S. Of course, this file does not really exist, right? So what I can do is I can open it with what? With X. So X will do what? X will simply just create that file if it's not there. Right? So that is that about that. Right? So ACSP, your hand is up. Please ask a question.
Okay. I wanted to ask, based on what you've told us so far.
Okay.
You said something about JSON 5 being very, very similar to Python dictionary, except from that there are some differences, about 3 of them. So I just wanted to ask, right?
Yeah.
You know, we have built-in function with Python dictionary, like whereby we can call in the values, we can append some values. Those built-in functions, do they work on JSON 5?
No, they do not work on a JSON structure. So data structure is just like a recognized means of structuring your data. Let's assume this explanation would make sense if you are stating the backend proper. All right, but I'll still bring it on though. Let's assume that you built a mobile app, right? That basically shows people a list of current news, right? And someone else, let's say Trump built a similar app, but then his own is a web app, and Trump built his own with, let's say, with Python, and you built yours with that. That is also a programming language. When I mean that, this is what I mean. That, not this one, please. not that, please. This I mean that this man here, and not this. So that here is a programming language used to build mobile apps, right? So let's assume that you built yours with that, and Trump built his with Python. But then Trump needs access to your data to use your information, right? Your content to populate his own application, right? Now you cannot hand over the keys to your database and give to Trump. If not, before you turn your eyes, Trump will wipe everything from your database. So what do? You do what? You can collect all the data in your database and do what, and convert it to a JSON structure and send it to Trump. His language will process that structure. So JSON is more like a means of arranging data for sending out to external bodies, or to exchanging information with other softwares, but with a different programming language. That's basically what JSON is, right? So there's no special ability to it. It's just a means of arranging data, and a general recognized means of arranging or of structuring data. So your built-in dictionary method will not work on JSON, except you convert that JSON back to your native dictionary, which is very possible. Is that understood? Sure. So even so, okay, Mary Jane, your hand is up.
Okay, can you hear me?
Yeah, I can hear you now.
Okay, I wanted to ask, so those how dictionary operates, is that how JSON operates too? Like, I mean, now we can store lists.
Yes.
We can store lists as values.
Yes.
And we can use tuples. Can we use tuples as keys?
I think just maybe you could the thing is that what you can do, you can simply just say record data type, JSON data types. So to save ourselves some stories, so these are the recognized data types for JSON, right? So so if there is tuple, I believe tuple should be available as well. But I know of numbers. So these are strings, objects. We have string, we have number, we have objects, we have array. So these are the only recognized one. So if you scroll down, so objects are basically anything that looks like this. So I don't tuple. I'm not sure tuple should work, but let's just go and try it and see, because you can just simply come here. Let's just try and see. Let's see. Let's come here and let's see. Let's put names. And so let's just say activities, right? Let's just say activities. Let's say you can have so already from what I'm seeing, right? We're having error self, so we can't have to, unfortunately. So there's no tuple, there's no recognize tuple,
No, I'm
but we can have
saying as the key, not value.
okay as a key. If you can have tuple as a key, no, all JSON keys are strings. Have to come like this, have to be input. All your keys have to be input. So you can't have tuple like this.
Okay.
Right. So
Okay.
all your keys have to be input. I think I haven't read an article.
Okay, even if it's a number.
Yes. Even if it's a number, the value itself can be of their own type, but the keys must be input. I'm making sense.
Okay.
Yeah. So these are your keys, right? These are your keys, and these are your values.
Yes.
Yeah. So the values can stay in their own type, but every keys must be input. I think I even read a blog that said that the keys must be in double quote. So let's just try single quote and see. Okay, so you can see all keys must be in double quote. All keys. So these are like a standard of structuring data, right? So all keys must be in double quote. Right. So that's our final test that theory. All JSON keys must be in double quote. All right. Any other question? Any other question? All right. So this is what we can do to store structured data. So you can say this one is more structured compared to our text. Our text are just random strings that can basically stay anywhere. I can still come here and have string that is staying here. Go there and have string that is staying here. Come here, have another string that is staying here. So it's just random, right? And nothing is wrong with it. But then if you need a structured way of saving stuff, then of course, please, you can have, this is a structured way, a JSON structure. This one is what is not Python structure, please. Is is language independent, right? It's a general means of arranging data, right? Okay, any other question? It's Fidelis.
It's from this JSON structure.
Sorry?
I said, can you get a user input from this JSON structure?
Yes, you can. Yes, you can import this file into. Yes, you can import this file. But since you can import this file, because every JSON structure, every language has a means of processing or processing this kind of structure, right? So of course we have that in Python, but then that's still boiled down to models. So if you are done model, then what we have done is basically do what? Import this file, or probably bring in this file into our function, into our Python script, convert it from JSON to our dictionary, right? So by default, Python knows what to do in that conversion, right? So it knows that this should be converted to capital T and not small t. So Python will do that. So it will convert all these things to your native dictionary, and then from there you can extract whatever information you need from it as similar to how you be doing when extracting with dictionary. Does that make sense? So I don't know if I've answered today's question, but that's basically what you would do. So any other question? All right, so in the absence of any other question, we will just leave it there. When we come tomorrow, we'll cover models, and then we'll come back and do what? And touch this file again, right? We'll come back and touch this file one more time. Any other question? Any other question before we run it up?
So you said tomorrow. Are we having class tomorrow?
Sorry, Thursday. I keep saying tomorrow. Thursday, sorry. All right. So the silence is not a question. All right, so we'll end it there and we'll meet again on Thursday. Let's have a fantastic time. And of course, please practice, and also prepare for this quick task. For this quick task, will cover a lot. Right? We'll cover wood. We'll cover so many things, right? Including models that we'll cover on Thursday. All right, so have a nice day. See you guys on Thursday. Bye.